Corrosion doesn't knock before it destroys pipelines, and not all corrosion looks the same. In this video, we'll break down the 5 major types of corrosion that every oil and gas professional must recognize before they lead to costly failures. Corrosion is the gradual destruction of materials, usually metals, due to chemical or electrochemical reactions with their environment. Different types of corrosion behave differently and require different strategies. Let's start with the most basic and widespread type, uniform corrosion. This form of corrosion occurs evenly across the entire surface of the metal. Imagine a steel pipeline exposed to moisture and oxygen. Over time, the surface starts to thin out at a consistent rate. It's like rust forming on an old car, but on an industrial scale. Uniform corrosion is usually caused by exposure to water, oxygen, or weak acids, and it's commonly seen in carbon steel pipelines. The good news? It's predictable and relatively easy to detect with routine inspections, like wall thickness measurements or ultrasonic testing. But don't underestimate it. Even though it progresses uniformly, it can lead to significant wall loss and eventually rupture if not properly monitored. In short, it's simple to manage, but only if you're paying attention. Next up is pitting corrosion, small in appearance but big in danger. Unlike uniform corrosion, pitting doesn't spread evenly. Instead, it forms tiny localized holes or pits on the metal surface. These pits can be just a few millimeters wide, but go deep, sometimes all the way through the pipe wall. The real threat with pitting? It's sneaky. It often goes undetected because the rest of the surface may look fine. But underneath, these pits can grow rapidly and lead to sudden leaks or even catastrophic failure. Pitting is usually caused by chloride ions, like those found in seawater, or from stagnant water in low-flow areas. Stainless steel is especially vulnerable when its protective film is damaged. In the oil and gas industry, pitting is a major concern in tanks, pipelines, and offshore facilities. That's why regular inspection and corrosion monitoring are critical. Pitting may be small, but it's one of the most aggressive forms of corrosion you'll encounter. Now let's talk about crevice corrosion, the kind that hides in tight, hard-to-reach spaces. This type of corrosion occurs in small gaps where fluid gets trapped but can't flow freely. Think of spaces under gaskets, washers, clamps, or between overlapping metal surfaces. Here's what happens. Inside the crevice, oxygen gets depleted over time, creating a stagnant environment. Without oxygen, the protective oxide layer on the metal breaks down, and that's when corrosion kicks in, often accelerating quickly. Crevice corrosion is particularly dangerous because it's difficult to detect until serious damage has occurred. On the outside, everything might look fine, but inside those gaps, metal loss could be significant. It's most common in stainless steel and other alloys, especially in marine or humid environments. The best defense? Good design practices, regular maintenance, and sealing or cleaning potential crevice areas. Because once corrosion starts inside a crevice, stopping it is a real challenge. Now let's look at galvanic corrosion, a type that starts when two different metals don't get along. This happens when dissimilar metals are in electrical contact and exposed to an electrolyte, like water with salts or impurities. Here's the science behind it. One metal becomes the anode and starts to corrode faster, while the other becomes the cathode and stays protected. It's a natural electrochemical reaction, like a small battery being created between the metals. For example, if you connect carbon steel to stainless steel in a wet environment, the carbon steel will corrode much faster than it normally would. That's galvanic corrosion in action. In pipelines, this often occurs at joints, flanges, or fittings where different materials meet. To prevent it, engineers use insulating materials, apply protective coatings, or carefully select metals with similar electrochemical potentials. Galvanic corrosion can be slow, but if ignored, it silently eats away the weaker metal. Now let's dive into one of the trickiest forms, microbiologically influenced corrosion, or MIC. Unlike chemical corrosion, MIC is driven by microorganisms, especially bacteria, that thrive in pipeline systems. The most notorious culprits: sulfate-reducing bacteria, or SRBs. These microbes live in low-oxygen environments and produce hydrogen sulfide, a corrosive gas that attacks metal surfaces. MIC often shows up in stagnant or low-flow areas like dead legs, water injection lines, or tank bottoms. The corrosion it causes can be localized, aggressive, and difficult to predict. Sometimes it even mimics pitting corrosion, making diagnosis a challenge. What makes MIC especially dangerous is its stealth. It often occurs beneath biofilms, slimy layers of microbial colonies, which shield the bacteria from detection and chemical treatments. Controlling MIC requires regular monitoring, biocide treatments, and sometimes mechanical cleaning, because once bacteria take hold, they don't stop until serious damage is done. We've covered 5 types of corrosion, each with unique characteristics and risks. Understanding them is key to prevention and safe pipeline operation. Want to see how these types are detected or prevented in the field? Let me know in the comments. Also, don't forget to share this video with friends if you find it useful. Like and subscribe to the channel to receive new tips about oil and gas corrosion.